dispersion, scattering, interference, and diffraction of light. Hello, I'm Kizia Bianca A. Fortuna, and this class has me as a designated student to talk about the difference of dispersion, scattering, interference, and the diffraction of light. So here are the contents of my today's presentation. 1. Dispersion. 2. Interference. 3. Light scattering. And 4. Diffraction of light. Dispersion is the separation of white light into its 7 color components when there is a refraction or bending of light. White light is composed of the different color spectrum: red, orange, yellow, green, blue, indigo, and violet. Each color has its own wave frequency. Different light frequencies bend at different amounts when they pass through a prism. When white light passes through a prism, it will refract 2 times, making the separation of the colors noticeable. So as you can see here, the picture example, a white light passes through a pyramid, which is a glass prism, and after that, colors appear. This is what we call the white light separation, and its 7 color components. Another example of this, which is the natural one, is the formation of rainbow. We observe that after rain, when sunlight passes through water droplets, we get a rainbow. Light scattering is the ability of particles to absorb light and scatter it in all directions. Scattering the light components depends on the size of the particles or scatterers. Small particles scatter components of short wavelengths, high frequency, while larger particles scatter longer wavelengths, low frequencies. Our atmosphere is composed of tiny particles that scatter the color components of white light. The atmosphere has an abundance in nitrogen and oxygen particles, which can scatter higher frequency components of white light. We scatter violet the most, followed by blue, green, and so on. This selective scattering is called the Rayleigh scattering. Our eyes are more sensitive to blue frequencies of light, which is why we see the sky as blue. Another example is the clouds. Clouds appear white because the water droplets in the clouds are larger than the wavelength of light, which scatter all the colors of light equally. This type of scattering is known as mist-scattering. Diffraction is the bending of light when it encounters an obstacle or an opening. A shadow is usually formed when light meets an obstacle. The bending of light is not very much noticeable, but when you look around the edges of a shadow, you will notice blurred areas or diffraction fringes. These are the areas where diffraction of light occurs. The amount of diffraction depends on the wavelength of light and the size of an obstacle. Also, the smaller the opening, the greater is the diffraction of light as shown in the diagrams A, B, C below. The longer wavelength, the greater is the diffraction of light as shown in the diagrams D and E. Example: diffraction effects are sometimes not helpful when viewing objects under the microscope. When the wavelength of light has the same size as the object, diffraction blurs the image. When the wavelength of light is larger than the size of the object, there is no image seen. Another example of diffraction is DVD. The closest spaced track on a CD or DVD act as a diffraction grating to form the familiar rainbow patterns we see when looking at a disc. As we reflect a DVD or CD in white light, we can see a rainbow in the surface of the DVD or CD. Interference is the result of the superposing of waves from different sources. If you examine a shadow formed by the diffraction of light, you will see fringes on the edge of the shadow. These fringes, or the interference of light waves, are the result of the diffraction of light at the different sides of the object or obstacle, which causes the shadow to be fuzzy. When this property was observed in the visible light, it was considered as a clear proof of the wave nature of light. There are two types of interference, which is the constructive and destructive. Constructive interference happens when two identical parts of two waves meet, such as a crest of one wave meets the crest of another wave of the same wavelength. This would result in a new wave with the same wavelength but twice the amplitude. Destructive interference happens when two opposite parts of two waves meet. For example, a crest of one wave meets the trough of another wave, which would result in the cancellation of the two waves. So this is the picture example of the interference. Another best example of the interference is demonstrated by the light reflected from a film or oil floating on the water. When you put an oil, CT, what we call oil of a motorcycle, we see reflection, rainbows on the water. The image below shows diffraction of light from two sources or openings. As the waves from these two openings meet, they interfere and produce interference patterns. The bright fringes are the areas where the waves interfere constructively, while the dark fringes are the areas where the waves interfere destructively. So here is the end of my presentation.